Hello, welcome to Lesson 2A-4 Mixed Solving Equations. Our learning target today is that I can solve equations. We've equipped you guys with several tools to help you use to solve these equations in the first three lessons. We're not going to really go into too much new today in the notes. What we are going to do, however, is to just take a look back at some of the things that you might have encountered as we've gone through these solving equations and just formalize things just a little bit more. So, as you might have noticed, as you've been practicing, we don't always get one solution. You might have seen the answer key sometimes no solution or infinitely many solutions. Alright, so we actually have three different possibilities that we may encounter, and we're going to take a look at each of those three today and kind of summarize examples of when you will see each case. So the first kind is the kind that is the most common, and that is one solution. So we are going to go ahead and solve this problem. If you remember, the first thing we need to do is distribute. So we're going to distribute this -4 on this side. Make sure we get that negative with it. A lot of times where we're messing up is that we are forgetting to distribute that negative alongside. But -4 times 8 is -32. And -4 times m is -4m. We also need to distribute on the other side to both pieces. A -4 times a +4 is a -16. And -4 times a +6 is a -24. And we have the m on there, so it's going to be -24m. Now, we need to get our variables on the same side of the equation. It doesn't matter which side we move. I like to work with positive numbers. So I'm going to move the 24 over to the other side. I need to add 24m to both sides. Alright, so we're still going to have -32. Now this is going to become a -4 plus 24 is a plus 20m. And that's going to equal -16 on this side. So we're going to add 32 to both sides. So we're going to get 20m is going to be equal to a +16. And we're going to need to divide both sides by 20. We're going to get m is equal to 16 over 20, which when we reduce, 4 will go into 16 4 times, and it will go into 25 times. So it's going to reduce to a fraction of 4/5. Now notice we get one particular answer. We get m is equal to 4/5. That gives us one number that we can plug back into here and make this statement true. Now don't be scared just because the answer was a fraction. It is okay to get answers that are fractions. That does not mean we've messed up. I've heard a lot of questions that are asking me if you have this problem wrong because you've gotten a fraction or decimal. Fractions are answers that are okay. As long as you plug this back into your original equation and you simplify it and you get that the left side is equal to the right side, then you know that you have done the problem correctly. So since we get m equals a specific number in this case, we are going to say that this has one solution. The next example we're going to look at is no solution. That is when we can't plug any number in that would make this work. So we're going to go ahead and simplify this. So we're going to still have on the left side 4x plus 27. On the right side we need to distribute though. We're going to distribute, we're going to get 4x plus 5. Alright, now, again, it doesn't matter which side we're going to take these to. Since I took it to the left in the last problem, I'll take it to the right this time. I'm going to subtract 4x from both sides. These will cancel. I'll get 27 equals. Now, if I look over here, this is going to cancel too. 4x minus 4x is going to give me 0. So that's going to be 0 plus 5. So when this simplifies, I get 27 equals 5. And that looks a little silly, doesn't it? We know that 27 is not the same thing as 5, but this equation is saying that 27 should be equal to 5. Notice our variable went away, and we're just left with two constants that are claiming to be equal to each other, but we know from our experience with math that 27 is not equal to 5. there's nothing that we can plug in for x that is going to make this statement true. So because there's nothing we can do to make 27 equal 5, we say that this is no solution. All right, no solutions will be one case that arises when you have your x's cancel out. If you still have an x somewhere, that means there's still somewhere that you can solve. But if your x's go away, one possibility could be no solution. Before we move on to that, I do want to point out one particular thing that will also help you catch when there's going to be no solution. If we look back up to where we first distributed, you'll notice that these problems look very similar to each other. They both have a 4x to start with, and they're both adding a number to the 4x. Now, we know if we have 4x over here and 4x over here, those should be the same. But if we add 27 to something and we add 5 to something, we know that there's no way that those are ever going to be equal. So that might be one place where you spot early on that this is no solution. All right, the other situation I was referring to earlier where your x's may cancel is where we have infinitely many solutions. I'm going to go ahead and solve this problem. I'm going to distribute the 3. I'm going to get 3 times x, which is 3x, and 3 times 7, which is 21. And on the other side, I'm going to get 3x plus 21. So again, I'm going to move my variables to one side. This time, I'll just go ahead and move them to the left. I'll subtract 3x from both sides. 3x minus 3x is going to give me 0. And 3x minus 3x is going to give me 0. I'm going to bring down both 21s. Now this time, I get that 21 is equal to 21 with both of my x's canceled. Now we know from math that 21 is equal to 21. Those are the same number, so they have to be equal. Notice that that is different than the last situation where we got two numbers that were not equal. Now, since these two numbers are always equal, it doesn't matter what we plug in for x. This is always going to be true. We can plug in 10, and 21 is always going to be 21. We could plug in 1,175,321 and a third, and it would still come out to be 21 equals 21. So the way that we labeled this situation is infinitely many solutions. You might also sometimes see this written as all real numbers. You might see either one of these on a multiple choice test or in an answer key. Alright, just like we had a little giveaway in the last one, I do want to go back up and look for just a second at our simplified forms. Notice on both sides, 3x plus 21 and 3x plus 21, we have the exact same equation. If you have the exact same equation on both sides, it is going to be an infinitely many solution. Alright, so just want to go ahead and summarize. We have three different situations that we can get when we are solving a equation. Our first example is one solution. Alright, that's going to be when we still have the variable and it's going to be equal to some number. Maybe x is equal to 3 or x is equal to 0. Now, one place that some people will get confused, if we have simplified a problem and we get 3x is equal to 0, notice we still have that x there, so we still need to simplify. A lot of times people will say, okay, this is equal to 0, it's going to be no solution. But that's not the case since we still have the x. What we would do in this situation is divide both sides by 3, and we would get x is equal to 0. And that is one solution. We have a specific solution, 0, that would work. For no solutions, we're going to get two numbers that are not equal to each other, claiming to be equal to each other. It might give you 27 equals 5. It might give you pi is equal to 0. It might give you 3 is equal to 7. They're all going to be statements that are not true. Finally, on the infinitely many solutions, we are going to get where the numbers are always the same. We might get 100 equals 100. We might get pi equals pi. We might get 3.1478 equals 3.1478. Alright? So those are three different situations to be on the lookout for as you're solving these problems. The one solution, the no solution, and the infinitely many solutions. Alright, hope this helped clear up some of the confusion over those. You are going to have some mixed practice from all three sections before. Go ahead and just do the odds in this section and then move on to the application. If we need to, we'll go back to the evens if you're still needing some extra practice. But for your initial assignment, go ahead and just focus on the odds. As always, let us know what we can do to help you out, and good luck. See you in the next video.